Good morning, children. Today we are going to learn about singlet and triplet states. Now let us try to understand first what are singlet states. Now all of us have heard about stable molecules. So now what happens in case of stable molecules? If a molecule is stable, it will have even number of electrons. All of you all must be knowing what are even numbers. In maths you all have studied in your school, right? Like 2, 4, 6, 8, etc. So stable molecules have even number of electrons which are paired in ground state. Now here let us try to understand it with the help of energy diagram. If a molecule is stable, the electrons will be in the ground state. Gs represent ground state. So see, this is a case of stable molecule wherein electrons are paired. You all can see one of the electron is having spin in the upward direction, the other one is having spin in the downward direction, and it is paired and it is having even number of electrons. So that is why this molecule is an example of stable molecule. Now in photochemical reaction, what will happen? If such a reactant molecule is exposed to radiation, it is going to absorb energy. So this particular stable molecule will now be absorbing energy. So after absorbing energy, what will happen? Electron will flip from the ground level to the excited state. Es represent a excited state. Now this is the second scenario wherein the molecule has already absorbed light energy and one of the electron out of two has flipped from ground state to the excited state. But you all can see, while flipping from the ground state to the excited state, it has retained the direction of its spin. This particular electron did not change the direction of its spin. So that is why even after changing the state, that is from S0 to S1, this still is spin paired. And that is why such states which are non-magnetic states, why they are non-magnetic states? Because one spin cancels the other spin since they are in the opposite direction. So these are non-magnetic states and that is why they are known as singlets. These non-magnetic states are known as singlets. So this S0, S1, they all represent different energy singlet states. Now we have to calculate the value of spin multiplicity, which is represented by capital M. So the formula is 2 in the modulus spin plus half. So 2 in the modulus, the electron which is having spin in the upward direction is represented by plus half, whereas the one which is the spin is directed in the downward direction, it is minus half. Plus 1, this plus half and minus half will cancel one another. So it becomes 0. This entire thing becomes 0. So 0 plus 1 is how much? 1. So the value of spin multiplicity for singlet is 1. And you all have to remember that singlets are diamagnetic. What are they? Singlets are diamagnetic. Why they are diamagnetic? I had already told you all that the spin magnetic moment of one to the other cancel each other, that is they compensate one another, and that is why they are diamagnetic. When you keep such molecule in the magnetic field, they will not split the lines of singlets further like this. The lines won't be splitted, it will be like this only, single line, right?